Hey everyone, this is Math Done Right, and in this video we're going to be talking about the end behavior of polynomials, and specifically when there's an even degree. So the degree of a polynomial is the largest exponent for the variable. Now this is important because if I have something like f of x equals x squared plus 7 to the 1,000th power, the degree is not 1,000. It's 2 because it's attached to my variable x, right? So the degree is only the number we care about for the exponent of the variable, and it's always the highest one. So in this video, we're talking about polynomials that have even degrees, so 2, 4, 6, so on and so forth. So let's talk about what their end behaviors look like. So to find out what the end behavior is, there's two cases for an even degree polynomial. It's going to be whenever I have a positive or negative leading coefficient. So what is the leading coefficient? So if I write down this polynomial, f of x equals x to the fourth plus 3x cubed plus 5, the leading coefficient is the coefficient that occurs on the variable that has the degree as its power. So I just said a lot. So let's write down what the degree is. So the degree for this one is 4, right? That's the highest exponent that occurs in the variable. Now the leading coefficient is the coefficient of that term. Well, right here, it's just a 1. So the leading coefficient is 1, and that's positive. Right? Another example would be like f of x equals negative 2x squared plus x or something. And then this leading coefficient would be a 2, or a negative 2, sorry. Very important that we have the negative 2. So you see there's two cases. Either leading coefficient could be positive or negative. So in this case it's negative. Alright. Okay, so now I can break this up into two different cases, right? If I have a positive leading coefficient, or if I have a negative leading coefficient. Remember, this is only if I have an even degree polynomial. Now the end behavior, if I have even degree with a positive leading coefficient, is going to be like this. So I know my ends are going to look something like this. Whatever happens in here, I'm not really sure about. But all I know is it's going to end like this. Both sides are going to point upwards. And then if it's negative, both are going to point downwards towards negative infinity. And then I don't know what's going on in the middle. Maybe we'll figure that out later. Alright, so now let's look at a few examples of this. Alright, so this first example is going to be f of x equals x to the fifth minus 3x to the sixth plus x squared. So first of all, let's find the degree of this polynomial. So I need to look at the highest exponent. So I have a 5, a 6, and a 2, right? These are all my exponents here. And I see that 6 is the highest one. So that's my degree, is 6. Now, I need to identify the leading coefficient, which I'm going to call LC. So to do that, I look at the coefficient of the x to the sixth term, and I get negative 3, which is clearly a negative number, right? So now I have an even degree polynomial with a negative leading coefficient. So what that means is that my end behavior will look something like this. Now later on, when we talk about how to graph a polynomial like this, I would usually start with the end behavior, and I know it ends like this, and then I would put in some stuff in the middle and then end like that on the other side. But for right now, we're just looking at the end behavior, and I know it's going to end like this. Alright, next example. Alright, this next one's going to be f of x equals x squared plus 5 minus 3x. Now, just like in the last one, it doesn't really matter what order these come in. All I care about is what is the highest power. And remember, for just 3x, there's like a little invisible 1 right here that we don't really write. But that even doesn't matter for this one because we can see that the degree is 2. So the degree is 2. And then the leading coefficient is the number in front of the x squared term. Well, it's understood to be a 1. So the leading coefficient is 1, which is positive. So that means that my end behavior will point up on both sides. All right, and this should make sense, right? I have a quadratic equation, right? So it should have the shape of a parabola. And now if I were to just, kind of, let me use a different color. If I go in here and kind of fill this in, my parabola might look something like that. But that's how a parabola points, right? It points both in the same direction. So, all right, those are a few examples of the end behavior of a polynomial with even degree, and the shape that comes about those is determined by the leading coefficients, if they're positive or negative. If it's positive, both ends point upwards, and if it's negative, both ends go downwards. All right, so in this next video I'm going to do, it's going to be odd degree polynomials, and we're going to look at the end behavior of those. All right, well, thanks for watching. Make sure you subscribe, like my channel, and all that jazz. All right, bye.